Waiting on the launch pad, driving my engines, listening for the countdown 10, 9, 8. I hear a voice shout, blast off. I'm ready, I'm smoking.
Snap, I break my earthly bond. Watch me, here I go, blasting up into the atmosphere. Can you feel me ascend the sky with my fury tail? Can't wait to breathe.
The planet's blue skin, with my nose cone, burst into space and see stars shining. In the middle of the morning, man in the moon, here I come.
Lots of things happen behind the scene for a successful launch of a rocket. The integration of the launch vehicle happens over a period of 50 days. The activities are carried out 24/7 around the clock in a highly synchronized manner, which is the hallmark of the resilience of Team ISRO. Favorable weather and wind conditions are a must for successful launch. Planning a launch requires accurate weather and wind profile modeling and prediction for the launch date. Ensuring safety at all work sites requires elaborate planning and assessment of accidental risk. The liquid fuel is loaded in the launch vehicle hours before the launch. Ensuring adequate supply and accurate loading requires careful monitoring of this activity. All activities before the launch till liftoff are controlled and monitored by the mission control room, which has the system to access the flight data from the launch vehicle.
To have to build a vehicle out of the lightest, easiest to put together components, then freeze it, expose it to explosive measures, noise, shock waves, aerodynamic effects, and rapid acceleration, and to have to do this in such a way that the ride is smooth and not damaging to your precious cargo. There is no other machine that mankind builds that goes through such extreme conditions, with these extreme requirements, with so little room for deviation. But keeping all of this aside, there are a few things that can go catastrophical in a rocket launch. There can be structural failures, including joint failures, engine failures, gyro failures, computer failures, radio failures, or self-destruction or command destruction. Structural and joint failures can cause fuel leaks, which can lead to explosions. Engine failures involve fuel leaks that can easily cause an explosion. Gyro failures can cause the rocket to not stabilize and potentially tip over and slam into the ground. Computer failures can incorrectly detect an abnormal situation, which can lead to an unnecessary self-destruction. Radio failures generally wouldn't cause an explosion directly, but many times the onboard computer will command a self-destruction upon the loss of radio signals.
Roaring,
Off the launch pad in a
cloud of smoke,
kicking off its invisible tethers to
earth, it blasts into space, blazing a
trail, searing the sky with its fiery tail.
After the failed launch of GSLV FO6 on 25th December 2010 due to small mistake by project director Tara Shinde, Rakesh Dhawan, a fellow scientist working with her, takes the blame for her. As a result, he is relocated to work on Mangalyaan as punishment. The new GSLV missions are given to Rupert Desai, a NASA scientist of Indian origin. The Mars Orbiter mission is thought of as an impossible mission by his co-workers due to its aim of reaching Mars with its tight budget. However, after the announcement of India's second moon mission Chandrayaan-2, the mission budget was cut by 50%. In between the tight schedule and minuscule budget, Tara and Rakesh continue to work on their MOM project by making several compromises. The team puts all their hard work and energy into solving the issues with the mission and making it happen. The actual scientists who invented the Mangalyaan together were Mileswamy Anuruddhai, Anuradha TK, Minal Rohit, Momita Datta, Nandini Harinath, Ritu Karidhal and Tessie Thompson.
The chances of this mission से तुम चाहते हो 800 करोड़ कहाँ से लाएंगे पैसा? It's impossible.
इस ट्रेजेक्टरी में 850
Go sir, go sir.
Go.
Also, the movie called The Rocket in 2013 was also launched. In 1950, a movie called Destination Moon was also launched. And in 2014, the most famous movie on rockets was launched, which was Interstellar.
It should be evident that each step in my career has resented on a firm foundation in mathematics. For me, the study of mathematics was the key that opened the door to the universe. Robert L. Stewart. An astronaut is a person trained by a human spaceflight program to command, serve, or pilot as a crew member of a spacecraft. The education required includes a bachelor's degree in mathematics, physical sciences, biological sciences, or engineering. Then it is required to gain 3 years of related experience after obtaining a bachelor's degree. A master's degree equals 1 year of experience and a doctorate equals 3 years. The maths required is college algebra, trigonometry, calculus 1, 2 and 3, ordinary differential equations and linear algebra. Now, the question arises that when is maths used? Astronauts use maths in order to make precise mathematical calculations from how the spacecraft leaves the Earth's atmosphere to how the astronauts pilot the craft. Designers use maths to calculate distance, speed, velocity and their own safety while creating spacefaring vehicles. Now we'll know about what are the different parts of a rocket and what are their purpose and uses.
The rockets that launch into space are made up of 4 major systems based on function. The structural system makes up the frame that holds a rocket together and consists of the cylindrical body, nose cone, and fins. Next, the propulsion system takes up the most amount of space and includes the rocket engine, fuel, and oxidizer. The payload system depends on each mission and consists of anything a rocket is carrying into space, like a spacecraft, satellite, or human being. Lastly, the guidance system is made up of radars and computers that provide stability for the rocket and control maneuvers in flight. In order to launch into space, all 4 of these rocket systems must work together to overcome the force of gravity. The launch begins when the rocket's propulsion system starts to generate a massive amount of thrust. Thrust is the force produced by burning fuel as exhaust gases escape through the engine. Once the rocket generates more thrust than its own weight, it lifts into the air to begin its powered ascent. During this phase of the flight, the weight of the rocket will constantly change as fuel continues to burn off. As a result, most space-bound rockets use a technique called staging to reduce dead weight and increase efficiency. The method involves breaking up a large rocket into 2 or 3 smaller rockets that fall away at different stages of the launch. As the rocket continues into orbit, its sophisticated guidance system maintains balance and steers to keep the flight trajectory on track. At the correct altitude and speed, the upper stage engine cuts off, completing the rocket's journey from Earth's surface into orbit.
The rockets have their origins tracing back to China. One of the first mentions of rocket as transportation was found in Chinese folklore. According to legend, a Chinese official named Wan Hu once assembled a rocket-powered flying chair. The chair had 2 kites attached to either side, each equipped with 47 arrow rockets. You can probably guess where this goes. On the scheduled takeoff, Vanu and his servants light the 47 fire arrows. The arrows did go off, but when the smoke cleared, Vanu and his chair were nowhere to be found. The gag is that if that actually happened, he was probably just obliterated by the blast. Definitely one of the funniest rocket facts. The next and the last fact is liquid fuel rockets are more powerful than solid fuel rockets.